All right, I think we'll get started. It's a couple minutes after. So first of all, thank you all for coming to this session. So ultra low power IoT and how an ecosystem really is needed to make it a reality. So first of all, I'd like to again welcome. My name is Fred Yentz. I'm the CEO of a company called IoT Launch. It's an IoT consulting company. It's my pleasure to host this panel. It's a very interesting topic in so many ways. People think that low power must be easy. You know, little battery powered devices, how tough can they be? But when you start thinking about massive scale IoT, whether it's trackers, meters, battery powered devices in the millions or the tens or hundreds of thousands, there's a lot of additional challenges. Battery life is key. How do you conserve power? How do you maintain availability? How do you keep them secure? How do you work with your operators to make sure that they stay connected? A truck roll can wreck a business case. So if the battery dies early, you're done. And there's a lot of tools in the network stack and in the entire IP stack that allow it to become more and more achievable. So this is really about beyond the module, beyond the protocol. People think if I pick the right part, I pick the right network, we're good. But there's some unique things that we need to work through. And we're here to discuss what I'll call sort of low power wide area network and beyond. We're going to explore how the industry has expanded to where this was kind of a cool thing to do to where now it's mandatory for business cases to work. Combining technologies like low power solutions, licensed and unlicensed, LoRa networking and the old Sigfox and the licensed spectrum. We have NB-IoT, low power Cat-M. We've got Red Cat that's coming along. We'll talk about some of those things. We've got localization with the networks, so you're not having to roam anymore. And what impact does that have on low power? We've got things like security elements we need to think through for SIMs and credentialing and verification. And we've got access into the hyperscalers. Most of this data is flowing into the hyperscalers. So how do we take this low power protocol that's really non-transversing into the cloud and have edge bridging and have the ability to do things correctly? So I'm joined by a highly distinguished panel of folks across the industry, which is great. We've got Swadeep here from Tata Communications, Americas, and they'll all introduce themselves and their company a little bit as well before we get into the conversation. We've got Payne from G&D. We've got Scott Lemon from Core Wireless, and of course Larry Tichavsky from Vodafone. So with that, I'd like to turn it over to each of you, and start with you, Swadeep. We'll just go down the line and take a few minutes and introduce yourself, your company, and then try to add like one important topic you think is key in dealing with this problem.
Hi. Tata Communications primarily brings in orchestration layer for the ultra-low power devices in the IoT space, and primarily with the multi-mode network connectivity, which is available globally, and also the intelligent connectivity management platform, which is primarily built in for the purpose of industry, right? So one thing which Fred was talking about, so the next phase of ultra-low power technology, right? So it could not be only about the low energy chipsets, but it could also be about the smart and adaptive connectivity that can orchestrate autonomously for the networks on the SIM card. That's what I feel, but of course, connectivity will always remain one half of the story of it, and the second half will always be the device lifecycle management framework, right? So that's what I feel. Yeah.
Hi everyone, I am Payne. I'm with a company called G&D. We're a 180-year-old company out of Munich, Germany, and most people know the side of our business where we actually invented the SIM card, and we're the largest eSIM provider in the world. So my experience is 20 plus years in building hardware and software solutions in the IoT space, whether it be high power or low power. So one of the things I think when I see this topic is just the reminder that there's not one solution, right? There's lots of layers to the device. There's lots of things that need to be done to ultimately get you to the goal of, I need the data, I need it accurate, So to meet those standards, there's probably some give and take, right? Maybe the answer is a bigger battery, right? But, you know, maintain focus on, I have something that's collecting important data that needs to be analyzed. How do I best ensure I get quality data, right? Because junk in, junk out, right? So definitely there's a lot of different techniques we can talk about to do that.
Yeah, Scott Lemon with Core Wireless. So we're one of the world's largest MVNOs with well over 20 million some devices that are deployed using our connectivity globally. We work with and have direct connections with about 45 different carriers that we connect to directly and manage SIMs across. We provide solutions to customers in just about any market you can imagine, from the micromobility scooters to medical industry and telehealth, to trucking, telematics, so just kind of across the board, and all sorts of obscure ones that you'd never think of. And yeah, this particular topic is one of interest because, as Fred said, it covers, there's so many aspects of it that you really need to consider. You know, in one way you might just think that it's easy to create a low power device, but when you really look at the modules that are being used, the protocols or the networks that are being used, and where you have coverage for those networks, and then getting into then the actual encoding of data and how you're transmitting, all of that starts to add up to cost. And it's cost in radio and battery in that implementation, but also dollar cost. And so there's often weighing of choices that have to be made there in all of that. So I'm sure we'll cover a bunch of these topics and have fun talking about it.
All right. Thanks. Good morning. I'm Larry from Vodafone IoT. I head up the technical initiatives for the Americas. If you're not familiar with Vodafone, Vodafone IoT is specifically targeted to connect IoT devices. We do that using 760 networks around the world, and we have about 215 million devices connected now. We're deployed in about 180 countries. And out of those 760 networks, we got 130 plus networks that are low power wide area networks. So NB-IoT, LTE-M, that facilitate connectivity. And then just one other number I wanted to share with you is 11, right? That's the number of years that on the Gartner Magic Quadrant that we've been picked as the leader for a connectivity service provider. So I think that kind of shows a vision of Vodafone IoT, not only what connectivity should be, but also executing on that vision. Probably the one thing I want to bring to this table is, obviously we spend a lot of time in rest of world deployments or global deployments. And we spend a lot of time with our customers designing a device or a low power device, not only to work here, on the host network that they're developing on, but also sending it out in the wild and, traversing many different networks with different settings, different environments, things like that. So really creating a low power device that survives and is robust in the environment that it needs to live in.
Great. So I have a magic number 11, so I'll ask you 11 hard questions. So, well, I'll start with you. When we think of devices, and you said it, when they live in the wild, right, there's differences between devices that move on, like transportation, containers, etc., maritime, telematics, versus metering that's planted in the ground next to a gas line. When you look at different countries and you operate in so many of them, how does provisioning and network profiles come into play?
Well, for us, when you talk about provisioning network profiles, so our solution mainly consists of what I call a homeless SIM. So it's a SIM that has no home country that goes ahead and traverses networks in a roaming scenario, right? So 90% of the time we're dealing with a single profile. And we're traversing this roaming network to provide connectivity in those 760 networks, right? What we'll do, there's a lot of times where you need to have a local profile for regulatory reasons. You can imagine Brazil. I think everybody, if they've tried to deploy in Brazil, they know what challenges there could be, that you need to re-credential into that local profile. And for that, especially with a low power device, that takes power and time and money, right? So So that's something that we pay attention to when we do need to go ahead and localize for a country for whatever reason. That, you know, how does that work in a low power construct? The other thing you were talking about was you know, sending it out into the wild, right? Well, we found we've had a lot of learning curves when taking advantage of the power saving attributes within a network, such as, you know, power saving mode or EDRX, right? There's no standard on how that should be set. So, so having a device that be able to go ahead and be able to recognize where they're at and be able to take advantage of that network the best it can is important. I think I answered your question. Okay.
There's 11 more topics.
Okay.
You started. So we're in an embedded world, and people do designs and they pick modules and they think they might be done. They get it to work on a bench, they make it work, etc. And I'd like to say that the Internet of Thing is easy. The Internet of Things is exponentially harder because, again, there's thousands or millions of things in many, many different geographies. And that we talk about orchestration. So I want to stick a little bit to the profiles and the localization elements, and let's switch all the way back here to Swadeep on orchestration. We think about this new SGP32. It's about profiles, right? If you've got a phone, you know, you click on the phone that says, you know, hey, I've landed in Europe. Boom, I want to download a new profile. An IoT thing isn't quite that simple. It has to do things autonomously. And some of the new standards that are here allow us to do localization a little bit more automatically. Can you talk to why that might be important, Swadeep?
Yeah.
Sorry.
So localization really makes a lot of sense for the use cases primarily because with IoT industry has been using SGP for a long time now, 0.02, 2.2, and now 3.2. But when it comes to deploying solutions for the low power, we need to make sure there is a minimal changes on the network which is happening because as much of the network latching is happening, so much of the power drain is happening, and the longer the devices are connected, the more the power is getting, you know, consumed as such. So we work with applets. We work with applets on the SIM hardware, where we orchestrate the profiles which would become active when a particular instance, business rule or instance is triggered, right? So, and at worst case scenario, when we really need to change a profile at an adverse scenarios, like could be a Brazil or any other new country going a local mandate or anything, then we use our SGP platforms appropriately to download the profiles. But more often we make sure we work with one profile which could have multiple network access. Primarily Tata communications have umpteen number of network access. We work with various partners. So the profile usually accommodates most of the scenarios and environments. But we do use SGP32 in a manner that it is very minimalistic when it comes to usage because the battery and the consumption is what we want to contain to the minimal when we are doing any of such maneuvering. Yeah.
Any comments on that topic?
Certainly, you know, localization from a public network thing is one scenario, right? When you start talking about profiles in SGP32 and, you know, you really start moving into a world where you're future-proofing your device, right? And especially in the low power markets, you know, metering, for example, right? Public network is not always what is preferred, right? There's private networks, there's private public fallback. And doing that efficiently, right? Whether that's at an applet level, whether that's at pushing a profile level, right? You obviously want to maintain the connectivity for the data, but you also want to be very concerned about the battery consumption, right? So I think that when you look at these new standards, it's not so much about, hey, I have this new fancy thing that lets me localize in Brazil, which is a great thing, or localize in Turkey. I think you look a little broader outside of, depending on what you're building, right? Is this something that at some point might need a private network, or is someone going to want to put this on a CBRS network at an airport or something, right? You want to take a look at how do I future-proof that device without the truck roll, right? You know, you never want to go out and touch the sun guard, right? So I think that's the important part. And what you're seeing is whatever I built on the bench, right? Whether I benchmarked it for cellular, I benchmarked it for cellular with LoRa backup, right? Whatever. I want to maintain a quality standard of signal so that I get the data, right? And I think, certainly when you start looking at the ability to remotely change how that device sends your data to you, that's a very important thing to consider.
Yeah.
As we talk about this, I just want to ask a question real quick. Quick show of hands. Are people familiar with what we mean by the SGP standards, the SGP 32 standard, and what profiles are? Anybody? So I just wanted to do this real quick because I realized that we live in this and we breathe it and we use these terms, and all of a sudden I realized a lot of it could be jargon to you and that you just don't understand. So when we talk about profiles, traditional SIMs, when you have your phone and you have a SIM card that gets put in there, you can think of profile as sort of like an image of that SIM. So that's one way to think of it. And now these new standards have SIMs that can support or hold multiple images and switch between them. And so when we talk about a roaming profile, that's an image of a SIM that allows it to roam all over the world, but is not necessarily tied to a specific carrier where you're roaming. And a local profile is one that is specific to a carrier. So maybe you come to America and you might get a profile that is a AT&T profile that's their image of that SIM, and that gets enabled, and now you're on AT&T's network. And so that's really a huge issue with as switching of these profiles starts to occur. And there's a lot of the flexibility. A lot of this, as you mentioned, is to prevent things like truck rolls. So you don't have to ever go swap a SIM in a device anymore. These eSIMs or EUICC SIMs give you this ability to change what SIM profile is in a device and activate it at any time. And that's really a huge thing for SIMs and connectivity in general, but then specifically the low power devices is giving you those options.
And one quick thing to add, right, if you look at it from a cellular only standpoint, 5G was really the opportunity where what I like to call exotic frequencies were introduced to the networks, right? And as any network provider, right, whether you're roaming or you own the network or whatever, you're migrating from LTE to 5G, standalone at some point, right? As Cat-M and narrowband migrate into those 5Gs, the specific location where some of those devices that you've deployed or put out, the frequencies available are going to change, possibly, right? And that's where that future-proofing piece comes in. It's not so much about which provider I'm on and what I see. Maybe it really narrows down to this provider is going to work better because the available frequencies for my device are better available now. It's, LoRa's LoRa, right? And that's great, and especially if you're building something that's got some sort of backup into it, right? You've got your gateway. It can worry about the cellular connectivity. But when you're talking about the individual device over the next, I'm going to say 10 years, as the transition from LTE networks to 5G only networks happen, your devices out in the field are going to see that I see different bands, I see different frequencies now because of changes that are being made by someone that's I'm not fully in control of, right? So, having that flexibility I think is just, important, right? And it helps you maintain those benchmarks moving forward.
So we're hitting a lot of topics, and again, when you think about the network and the network choices you have, we'll kind of do an analogy, right? So in the unlicensed world, you have LoRa or you have private bands, depending on what's going on. But you have this LoRa network. It's very flexible and it's good for local area coverage, and then you have gateways and you move the data off to where it needs to be processed probably. And then there's the next level, you could call it NB-IoT. Again, we're filling you with acronyms. If you know these things, I'm sorry. If you don't know them, then you'll find this interesting. Again, very low power, but it's probably the most restrictive when it comes to roaming and other things. Great if you're planting meters in the ground and they're not moving. It works perfect. Then you kind of come up to LTE Cat-M. So in the LTE world, that would be like the lowest amount of data and throughput that you would get. And it's pretty efficient, but it's much more flexible for roaming. So, those are kind of the three low power. But then if you're moving around a lot in the container or whatever, people started with Cat-1 because it was the most flexible, but it had some other penalties in terms of power usage. So, it's a multi-dimensional problem, guys. And, I think, Larry, you can talk to, again, you have so many networks and you have so many use cases across your customers. Do you see a lot of need for multiband that people are using LoRa and licensed in their solutions? I mean, you're not a LoRa provider typically, but do you see that?
For us, I mean, we see LoRa generally, we're backhauling LoRa networks, right? There's remotely, you're setting up a private LoRa network and covering an oil field or something like that, and you're using cellular to backhaul that information off. So to me, I don't see a whole lot of devices that are equipped with narrowband cellular and LoRa at the same time. It's generally, you're using like this low power wide array network, either NB-IoT, LTE-M, for low power. And picking between the two depending on what your use case is. Like you said, meter, sticking in the ground, very low, you need signal penetration, those type of things compared to, I need some element of mobility like LTE-M provides you. Now, one thing you brought up, Cat-1, right? That's one of my favorite technologies because, Cat-1, and now there's this new technology, newer, I guess, Cat-1 bis, right? That does give you some simplicity and some power saving that approaches like LTE-M. And the neat thing about Cat-1 is it's ubiquitous, pretty much. If a carrier adopted, what was it, release 15?
Right.
So 3GPP that includes that. It's built into, sorry guys, sorry about that.
Standards committee.
Well, if they, carrier upgraded to the latest version of software that supports Cat-1, it's, inherently in that network. And so now, when I said this morning, 130 networks, well, now that opens it up to like 480 networks that support that, right? So that ubiquitous coverage, especially on the global front, is really important because it's all about the connectivity. I mean, you have to get it connected, right? And that's the value that we bring. So, to me, I mean, don't see a whole lot of LoRa, just from my perspective, and just my view of the world, but I'm sure it's out there.
So you might have a different perspective.
Yeah. So honestly, in US, we have put in LoRa network in our lab, and we are trying to go live with a POC for a customer. But what we could achieve with LoRa solutions that we have deployed elsewhere is that we have seen when we're offloading the network computation, right? When we're offloading the network computation along with the MEC. Now again, it's a thing, but when we're doing that and offloading it from the device, then we see a lot of battery savings, right? And in fact, to the extent of 15 years plus, that's the kind of savings that we have seen. And it helps a lot for the device longevity because we expect these devices to work in the field with batteries not getting changed. We are not expected to go and do a servicing for them, and therefore from LoRa, what we have seen is that's one unique aspect of LoRa, that it gives a lot of control on the different boxes in the landscape that can be moved around the place. That if you think a certain part is actually consuming a lot of power or adding to the battery drainage, we can quickly plan a way of moving it out and having that work done off-node, probably to the nearest node or somewhere, right? So, I mean, a case in point is one of those new chipsets which have come in the market, which uses AI processors, and these processors enable the sensor nodes to actually do a classification of anomaly versus an actual data that needs to be sent back, right? That way, actually, you save a lot of energy, and that increases our performance by 90% of the devices. So that has been our experience so far.
So there's other networks as well. There's little things like Sidewalk and Helium, which was built out. I don't know if you guys know of Sidewalk and Helium, but there are other choices. With regard to moving data through, when these little devices are talking, from the device up to the network, the other element to try to save power is to minimize that payload as much as you can. So you want to transmit as very little as you can to be meaningful, to reduce the payload size, to reduce the radio time, and to reduce the cost of the data plan. So, Scott, you've got a lot of customers that are out there doing cool stuff. And, talk to that for a minute.
Yeah, I
How do
think
they keep it secure? Because an optimized payload usually doesn't have security wrappers in it and all kinds of other stuff. And security is a big deal.
Yep. No, that really is probably one of the biggest things on low power, and even just on cellular in general. Like, we find that a lot of the technical people who are developing the firmware and things, often as they're new to cellular, don't think about the fact that you're paying dollars per megabyte or cents per megabyte. And at that point, every single byte counts. And when they're used to posting a big JSON payload up to the cloud because it's beautiful and verbose and nice, we found times where they're sending probably 10 times the amount of data that they need to. And you think of that as dollars, but then, as Fred was saying, that's also transmit time. That the radio has to be on that much longer transmitting those bits, and you're burning a battery. And so, that's a real key area of how to look at, other alternate protocols that are more dense, how to reduce the data payloads, how to prioritize payloads. And this is going to become, in our opinion, even more important with satellite. Because as people start to fail over cellular to satellite, you're going to want to have prioritized queues of, well, what data is it worth and necessary to send over more costly, even more compact satellite versus when I get back to cellular and now I'm going to DQ or send other data. And then, as Fred said, in security, there are lighter weight protocols that can be used that have levels of security at much lower layers. Again, a lot of modern, I hate to be generational, I'll say this as an old person, I'll say generationally, people who are used to the fact that they just have SSL and TLS and can do big JSON payloads and all those things, when you come to cellular, it's really going to be a wake-up call if you need to look at the details of both that financial cost and the battery or energy cost.
Any other thoughts?
Certainly right when you're at the data layer, whether you're looking at UDP, or any of the security protocols that go along with it. I think that's important. We touched on, and I think Fred, you mentioned RedCap just for a second, right? So certainly future-proofing from what are the networks going to offer me, right, type of stuff. RedCap, which is reduced capacity for 5G, is certainly something important to start looking at. Now, you do have some decisions, and depending on how nosy your finance department is, right, it's, am I looking to future-proof my device? RedCap is more efficient from an antenna and an RF perspective than some of the CAT, LTE type products that it's replacing. Is that chipset going to be as cheap as an LTE-M chipset? No. But do you need a little bit more speed? Do you need, maybe more ambiguous coverage? What Cat 1 is today versus Cat M, right? So I think as you're building devices for cellular specifically, there is a trade-off, right? Do I spend 4 times more on a module today, but I get the benefits of a wider area network at some point, I get some longevity, or do I stick to Cat M where, still sub $10, right, from a module perspective, and maybe go through some painful frequency changes, as the networks mature into 5G standalone, right, along the way. It depends on your solution, right? And I think as long as you are going out there and saying, look, I need something cellular, or I need something that's got a couple of different things in it, maybe, right? You've got to look at the long term, whether that's profile switching, what networks it's going to be on, what networks can it be on, and determine, what's the most valuable piece? And it's typically the data, right? Certainly in a perfect world, unfortunately, most of the full stack solutions out there, hardware is kind of a necessary evil, right? So I would definitely look at a lot of the newer stuff, including RedCap, just from the standpoint of if it's going to be out there for a really, really long time, maybe it's worth that investment, right? And you find ways to build that into the ROI story right out to your customers. But you know, certainly RedCap's early. It is a little expensive, but it does, if you do some comparisons, right, there are a lot of battery saving advantages over Cat 1 as you move into RedCap.
Everybody wants to
Yeah, I was
comment
just
on
gonna.
that. I'd love to jump in on that.
You got it first. I was gonna say, yeah, I would add to you touched on it, is time horizon, right? You know, that's RedCap is something that we're checking out and tracking, as well as eRedCap, right? Which is enhanced, reduced, capability. But also that time horizon. So, you know, I want to build a device that will survive many, many years. But if I want to deploy it now, I got to look at where am I going to deploy that, and is that technology available, right? And if it's not, what am I going to be using in the meantime? And so, the neat thing about in the U.S. is, I mean, we got 3 major carriers that are very aggressive in their technology and deploying technology. And it's once they do, it's ubiquitous. It's here in the U.S. We don't see that in the rest of the world. You know, there's probably some of those MNOs that 760 footprint that probably couldn't spell RedCap today. And then if your device is working on that, well, then that's something to consider, and kind of a balance of time horizon and then also the technology available.
Just one real quick, yeah. I think that you touched on some great points, which is, you know, both of you, on that time horizon, when you hear about these standards, the carriers would love for you to go spend your dollars and support what they're investing in. But if you were to look at a lot of the analysts, they're saying that 4G LTE deployments will not peak until 2030, 2034. And during that time frame, if those are true and that's accurate, even if some carriers begin to turn it off, other carriers are going to see that as an advantage. And even if you saved yourself 2 years on investing in RedCap, how much cheaper will the modules be? How much cheaper will the technology be? And we see, you know, talking with our customers, a lot of people who are seriously analyzing that to say, okay, we want to be aware of the future, we want to look to invest in the future, but when does it make sense to do that? Is it today? Is it next year or the year after? And are we really losing anything if we continue to invest in 4G LTE for right now as all these costs come down and technology solidify? So that's sort of the flip side of the coin in evaluating those things.
Yeah, exactly. I mean, with a customer who is a smart meter operator, right? So he started on this journey at a very early stage, and we got it deployed on LoRa. Soon we realized his necessities, needs have changed, and then we had to put him onto NB-IoT and new deployments. Now, in the third phase, now we have put in a combination of NB-IoT and LoRa together as a backhaul. Now we have RedCap coming in, right? So the work on RedCap has started, but the previous deployments that we have done are still yet to yield the results, right? So this has been one challenge for us, as well as being that you have a technology, you build it in a manner that is now economically viable for the industry, because the first time the technology comes in, the devices, the chipsets, everything are costlier, and to make it happen for the customer, you need to bring in that volume into it. And like Scott just mentioned, like I believe the peak would happen in a few more years, and thereby probably the RedCap would come in and probably start making sense for the industry. But till then, right now, we are really making sure what we invested are actually reaping it out. Yeah.
Okay. When you're developing a hardware device, an embedded hardware device, and you pick a module, whatever technology you decide based on all the confusing things we've told you today so far in terms of choices and economic challenges and strategies of the carrier deployments of some of these things. But you're going to have to author a client. You're going to have to package that payload. You're going to have to put something down in that firmware. It might be bespoke. It might be just encoded binary. It might be CoAP. It might be UDP. You guys will figure that out. You're going to probably push it through because it's going to be optimized an APN or some type of a secure wireless pipe to the core network. And then you're probably going to have your customer say, I need to terminate that in a hyperscaler. I need to terminate that in Azure, AWS, GCP, somewhere. Depending on where your application lives, a lot of your protocol, radio turn on, send the data, and get an acknowledgement back, if those acknowledgements and those endpoints and radios aren't closer together, again, that's more radio time. So we talk a lot, I talk a lot, I've got other interests as well around edge bridging. How do you upscale that protocol so that it natively goes into these clouds? Because what you're sending off of that device will not ingest in any hyperscaler at all. It's like putting rickshaws on the Autobahn. It just doesn't work. You need to do some middleware in flight to do that. And I know, Scott, you and I talked a little bit about this. Why is this important, and how can this help customers speed implementation and reduce power?
Yeah, I think this is great. I love your term, the edge bridging like that, because that's where, again, people often who are coming into cellular start to look at how they developed on other environments, even Wi-Fi or something else, and they think about their device talking end-to-end to the cloud and using a particular protocol. And this alternate approach is to say, no, I can now have my device send very minimal compressed, you might be using protobuf, or you might be using some other low-level protocol to compress that binary data, and then get it to that middleware that has the ability to convert it to a format that's understandable by your cloud developers, and that starts to use a more standard protocol. And so you're keeping that low, and there's also some added benefits, which is if you have that middleware in place that's doing a translation, if you even introduce an alternate device or a second generation of the device, and it sends even a slightly different compressed format, well, your middleware now has the ability to massage it into the same cloud-facing format. And so you start to get transformation capabilities that can be done in that middleware. And so that becomes sort of a data orchestration layer that can now better manage the data flowing from devices in very compressed formats into what the rest of the development team and development environment might be using.
Okay. So I think a theme might be, if you've got a device that you're building for 10-year lifetime, you probably don't know everything you need to know today. That's just the fact. No one's got a crystal ball that good. If the five of us had a crystal ball that good, probably one of us wouldn't be here today. We'd be on a boat somewhere. But I'll tell you, the key is, how do you keep your deployment and life cycle as flexible as possible? So, you mentioned network orchestration. You mentioned, a variety of operators and a strategy that allows you to move flexibly through that. You mentioned data orchestration. How do you have the ability to kind of in real time, as the world changes, as a geopolitical event happens, and now your utility company in Canada says there's no data crossing the border to the US, you better have your servers all in Canada, right? There's all kinds of things we can't predict going forward. So the ability to redirect that traffic, the ability to localize, on the radio network, I was going to say RAN, the radio access network to the operator's core to maybe your server that has to be in country. But you're the poor embedded engineer that designed a meter that, you really had no idea that these things were going to happen. So, flexibility is the key, the big F word, flexibility. And I think the other thing that's really, really important is you need to think like an embedded engineer. That's why I love doing this talk here. The world is full of application programmers that just grab sample code, throw stuff together. They have infinite storage, infinite compute, infinite everything. But when you're dealing with low power devices, please be yourself. Think like an embedded engineer. Think like you're writing assembly code. Think like you're optimizing every byte. Because if you don't, you won't build the best device you can. We're running out of time. I'd like everybody to take and I've sort of summarized my closing thoughts, but if we can start from you, Larry, come back this way, that would be great.
Okay, so through this talk, my summary would be, we talked about longevity. We talked about the time horizon, how you balance longevity to the time horizon that you need to deploy. We talked about the complexity of deploying globally and and how do you navigate that? I would think the other thing, I don't think we touched on it a little bit, but I just wanted to also touch on security, right? We sort of we have a constrained device. It's going to be, constrained in encryption sometimes. So that secure network and, talking to like an edge bridge simplifies that. So I guess there's many components to a battery constrained or a power constrained device, and it's difficult to manage it all together. And so I think that's why you really need to rely on partners that do this kind of stuff every day, and there's quite a few of them out there.
Yeah, I'd have to say I agree. As it's probably become obvious for people who weren't familiar, it's a very complex landscape. I mean, there's many moving pieces in cellular, the standards, the evolution of the standards, and the one advice I tell customers all the time is, reach out to multiple companies and talk to them and learn and get your questions answered. Because you'll often hear different stories from different companies. You're going to hear and gain information and knowledge from each of them that will allow you to make really good choices and just learn more about it. And that's probably the biggest thing that I can say to anybody is do your legwork, do your research in advance to really learn this, to not make some potentially poor choices that could cost you later.
Yeah, I mean, certainly the flexibility, I think, is definitely one of the most important topics. There's so many pieces of the cellular wireless networks globally that are just going to be out of your control, right? So if you give yourself flexibility, you're not afraid to, make mistakes. There's lots of companies out there that are making their first cellular device, right? They've been doing Wi-Fi or they've been doing something else, right? Cellular's just different. It is. But it's a great technology. It's got lots of different options, and it gives you that wide area network, right? So it gives you the flexibility to maybe launch in 3 markets, then go to 7 markets, whatever you want to do, right? But there's lots of different ways to be flexible across technologies, hardware. You can do a lot of your homework, but the cautionary tale is always that this is also a very fast-moving industry. So things change quickly. So find friends that understand things and are up to date with what's happening, because go open your phone. There's somebody writing about 6G, which we didn't talk about somewhere in a news article. So
I got the AG post.
the 8G. So but that's it. I appreciate everyone attending.
I think it all starts with the customer's requirements, and today he would want to do X, and tomorrow after doing it successfully he would want to do Y, Z as well. And that's when the technologies, as consultants, we might advise them to change and evolve, right? So I keep talking about this very often, that the smart meter, I believe Vodafone, deployed in municipality in France. It works in 2 AA batteries and it is still working fine. It's been 10, 15 years. That's what I read about it. But that customer is still happy today with that particular technology. We don't have to go back and change or do anything, right? So while 6G comes, we will have something more than RedCap or eRedCap, right? So the technologies are always there. It's about the customer needs and requirements, and to ensure a little bit of foolproofing and make sure through the SGB platforms that the devices and the solutions are lasting for longer. That's what I feel. Yeah.
Great. Well, I'll tell you, keep your mind open and think about the possibilities. Things are changing fast. I mean, I'll hold this up. This is just an example of a low power device. This is a LTE device. It's a sticker. It goes on a package. It can send hundreds of signals about where I am and the condition of the pharmaceutical might be, etc., depending on what it's on. You might be doing an embedded asset that goes inside of a vehicle. That's a safety device, electronic driver, log device. There's all kinds of things you might be designing, but think out of the box in terms of what you can do, and then think very much in the box about how to make it efficient. I'd like to thank the panel. You guys have been great to work with to get ready for this. I'd like to thank the audience. We don't have a session right behind us, so if there's a question or two that somebody would like to ask publicly, I'd love to take it. If not, we're available to come on up and ask the private question. There's there's no dumb questions, by the way. This is complicated if you haven't played in the IoT world before. I think, you know, we said flexibility. I said flexibility, but the best thing is find a friend, right? So kind of phone a friend and stay flexible. And I think, you know, we can make you successful. We will do our, you know, do our damnedest to make you successful. And that's it. So with that, we'll bring it to a close unless there's a question by anybody. Oh, we've got one.
I've got lots of questions.
All right,
So,
shout it out and I'll repeat it.
First one, nobody talked about PTCRB. Can we talk about that a little bit, and maybe just even a high level on what is PTCRB, and you know, how are you guys dealing with the verification of it? You know, what does it mean? Like, you know, how does it help? Is it protecting us against denial of service attacks and things like that? Just to frame up the question, maybe we can talk about that for a minute.
Well, I mean, you got.
So certainly, PTCRB is one of the necessary cellular certifications in certain countries, right? Different parts of the world have a lot of different certifications, whether it's RED, CE, things like that, right? PTCRB is always encouraged, right? And really what you're trying to do is make sure that, again, you've got devices that play nice with the networks, right? And if they don't play nice with the networks, it's only going to hurt the data you're trying to get out of that device, right? Now, there are a lot of certifications, maybe carrier certifications, that you don't necessarily always have to jump through those hoops if you're not using certain carriers. But I think certification of your device gives it credibility, but more importantly, again, it goes back to, at the end of the day, you've got to get that data right. And if the RF levels and different things are not operating inside your device properly, you're not going to get the right data. So there are lots of really great labs that are out there, you know, that do PTCRB every day. They do FCC, they do CE, whatever, right? Find a good one and just go through the process. Is it costly? Yes. But there's certainly different layers of certifications that, depending on what you're deploying, where you're deploying it, and who you're deploying it with, maybe from a cellular standpoint, that, you know, there's certain certifications you have to do and some that are, I would say, optional.
I think one of my questions was more maybe a level deeper on that. Like, so, like, let's use Core as an example, right? So if you're using a Core SIM and you're connecting, and then the backhaul is going over a Verizon, right? It's going to require, you have to have Verizon's PTCRB, or it kicks you off and you're not getting a connection, right? But is it going to connect to another service, right? Or, you know, those kinds of things is like, what's the level of risk if you put something out in the field and you want it to connect in no matter what? Because one of the value adds in Core, in my opinion, not understanding a lot, but, you know, is it that you can work with anybody's service, right? So there's this value add. So are there checks so that you're going to get access, or how does, maybe talk a little bit about that?
So the answer is it depends. That's the best. No, so what's interesting is, like, we have a pretty broad portfolio of SIMs and connectivity solutions we can provide. If you're getting a direct Verizon SIM from us, Verizon has, as he was mentioning, very specific requirements related to using a Verizon SIM on Verizon's network. So there, they often require the certification from Verizon, and they won't, and that's different from PTCRB. So PTCRB is a more generic certification at sort of a certain level that isn't carrier specific. And again, we highly recommend PTCRB, but there's a lot of cases in a lot of countries it's not required. You don't have to do it. So in the cases where you do a Verizon certification, Verizon is probably the stickiest one that we deal with on certifications and things, and they actually register the IDs of the devices in a database and just flat out won't let you connect to their network. If you're using one of our roaming SIMs, the roaming, what are called IMSI sponsors, have reciprocal negotiations and agreements with people like Verizon and AT&T and T-Mobile where they don't require the carrier certification. And at that point, they also don't require the IMEI registration. So the serial numbers of the device don't have to be registered. And so I can use one of our roaming SIMs, pop it in one of my test devices or a device at my house, pop it up, and I can have it go from AT&T to T-Mobile to Verizon all day and all night, and there's no problem. Didn't have to be certified. There's no restrictions. I don't get blocked from Verizon. But there are these cases. And now as we get into, as we were talking about the standards, SGP32, for example, and we start to get into the multi-profile, which you can think of as having multiple SIM cards in your device, we'll have solutions where you might be on the roaming profile initially, which might have some cost implications in battery life or other things, and we can download a Verizon profile if you've got the certification on that device and switch to it, and now you get the benefits of a direct Verizon connection. And if something goes wrong with Verizon, the SIM through an applet, as was mentioned, could actually trigger and switch you back to the roaming, where all of a sudden you get access to AT&T and T-Mobile, so that your device can recover until it can get back on Verizon. So kind of there's, again, it's not a simple answer. That's why I kind of joked with it depends, because there's all these little intricacies of which SIM, what carrier, and what the different requirements are.
And the carrier rules change too, because some carriers allow permanent roaming, some don't. So there's also the environmental attributes of the market that you may not control. And they may allow permanent roaming today, and they may not allow permanent roaming tomorrow. So,
Related to that, we had a customer, I forget when, that was like, wait a minute, what do you mean they have permanent roaming? We've had devices there for 3 or 4 years and they're all still working. which is kind of interesting. I know, yeah, keep that down and don't count on it in a permanent roaming country.
Yeah, and I think just one quick thing to add, right? So most of us on stage deal with like multi-MC profiles and things like that, which are honestly not necessarily always the best solution for a battery constrained device, right? So just to finish your PTC RB question, right? Even when you start moving into some of the eSIM standards, right, it still kind of comes down to, you know, is that, and I'll say, you know, is that T-Mobile profile something that you are getting through a roaming profile? Or is that T-Mobile profile a legit T-Mobile on Payne T-Mobile profile? Changes the game when it comes to certifications, right? Your access to the network, honestly, isn't very different, right? So a lot of it depends on how many SKUs you have, what countries you're deploying in, right? If it's one device, very narrow, North American focus kind of thing, then maybe you bite the bullet and you do some things, right? Unfortunately, the answer is always going to be it depends sometimes. And whether is permanent roaming allowed?
it depends sometimes. So hey, we're gonna bring this to a close. One thing that the 5 of us have in common, we have a lot of things that are not in common, but one thing we do have in common is we're all members of IMC, who brought you this panel today in cooperation with Embedded World. And IMC stands for the IoT M2M Council. So we have a variety of what we will call sustaining members, or they're the people that bring technologies to the market, and all of us here are sustaining members. And we also have about 28,000 buyers in our network, companies from around the world that basically are procurers of IoT devices and IoT technologies. So it's a great place when we said, you know, stay flexible. Well, that's your problem. Find a friend, we can help you with that. So come and visit us at Pavilion 6021 downstairs if you want to get more information on IMC, how you can become a member, sustaining or just a consumer side member. So thank you all very much, and have a wonderful rest of your day here in lovely Anaheim.